Hello, my friends. As you lie here, ready to drift into rest, imagine Earth not as the familiar place of cities, lights, and constant motion, but as something older, deeper, and layered with forgotten chapters. Beneath the surface, within stone, soil, and the silence of time, lies a question that has fascinated scientists, historians, and curious minds for centuries. Were we truly the first civilization on this planet, or are we simply the most recent? When we look back at human history, the story seems fairly clear. We often begin with the earliest known civilizations. Mesopotamia, nestled between the Tigris and Euphrates rivers, where farming communities slowly transformed into bustling cities. The ancient Egyptians, raising pyramids along the Nile, leaving behind monuments so enduring that they still rise against the desert sky thousands of years later. The Indus Valley people, who built carefully planned cities with water systems and standardized weights, even though their written language remains undeciphered. The Mayans and the Olmecs of Central America, the dynasties of China, and the empires of South America. All of these are stories of human beings organizing themselves, farming, trading, creating art, and building stone structures that seem to speak to us across millennia. And yet, when we step outside the comfortable frame of the last 10,000 years, when we move further back into deep time, the landscape changes dramatically. Civilizations become invisible. There are no stone temples, no inscriptions, no planned streets. What remains instead are rocks, fossils, ice layers, and sediments. The written story disappears, replaced by the slow language of geology. It is in these layers that some people begin to wonder, could there have been something more long before the Sumerians, the Egyptians, or the Mayans? Could there have been a civilization, or even many, that rose and fell so long ago that all physical traces have been erased? To answer this, we must think carefully about what evidence really means. Consider our modern world for a moment. Towering skyscrapers, vast networks of roads, countless machines, satellites, and cables. To us, it feels permanent, almost indestructible. But in the scale of geological time, permanence is an illusion. If all humans disappeared tomorrow, how long would our world last? Within a few years, buildings would begin to crumble. Within a few decades, vegetation would spread over highways and cities. Within a few centuries, metal would corrode, glass would fracture, and even the largest structures would weaken. In a few thousand years, forests would reclaim much of the land, and rivers would wash away bridges. In tens of thousands of years, only the most stubborn traces, ceramic fragments, perhaps some plastics, and radioactive isotopes would remain scattered. And yet, even those fragments are fragile in the scale of millions of years. Plate tectonics slowly swallows land into the mantle. Erosion grinds mountains into dust. Ice ages advance and retreat, carving valleys, redistributing oceans, burying entire landscapes under glaciers. To see the Earth's surface is to see a constantly moving canvas. In this restless shifting, almost nothing is truly safe from erasure. It is sobering to realise that if another civilization existed tens of millions of years ago, even one as advanced as ours, the odds of finding a single clear artefact today would be astonishingly small. This is why scientists rely on indirect evidence. They look at patterns, anomalies, signals hidden in geology and archaeology. In recent decades, questions about the possibility of earlier civilizations have sometimes entered public conversation. Most scientists remain cautious, because evidence must always guide speculation. Still, the thought lingers. If civilizations before us existed, they may have left behind subtle signatures. Not grand monuments, but chemical markers in soil, unusual isotopes, or disturbances in fossil distribution. But let us return to the more familiar world of our own ancestors. For the last 300,000 years, Homo sapiens has walked the earth, and before us, other hominins lived, adapted, and vanished. Neanderthals, Denisovans, Homo erectus. Each species lived lives rich with survival, cooperation, and culture, though their remains are scattered and fragile. In caves across Europe, archaeologists have found paintings made by early humans, some dating back tens of thousands of years. Simple tools, stone blades, bone needles, and ornaments carved from ivory appear in layers of sediment. These are the earliest confirmed markers of symbolic thought, the first chapters of what we call civilization. But what if these chapters are not the beginning, but the continuation of a much longer, hidden story? It is easy to imagine our planet as static, holding everything in place like a library shelf. But Earth does not work this way. The surface is rewritten constantly. Oceans advance and retreat. Glaciers expand, then melt. Forests rise where deserts once were. Entire rivers change course. Cities like Uruk or Mohenjo-Daro lasted for millennia and left behind walls, streets, and artifacts. Yet in a million years, even those walls may vanish entirely. Multiply that by 50 million years, and the possibility of finding anything recognizable seems faint indeed. This raises an important thought. When people ask if we were the first civilization, they often imagine something just like us, complete with buildings, machines, and tools. But perhaps the more realistic question is, how would we even know? What sort of evidence could survive long enough to be discovered? And is it possible that traces we already see, strange anomalies in carbon layers, unexplained changes in climate records, could in fact be the fingerprints of a lost past? Of course, science demands caution. There are many mysteries in Earth's history, but most of them eventually find natural explanations. An unusual layer of sediment might at first seem artificial, but then turns out to be the product of volcanic ash. A shift in climate could seem mysterious until explained by orbital cycles. Still, as long as there are gaps in our knowledge, curiosity will persist. That curiosity is not unscientific. It is, in many ways, the beginning of science itself. The willingness to ask what might lie beyond the limits of what we know. So tonight, as you listen, we will not try to prove hidden civilizations. Instead, we will walk calmly through the evidence, the history, and the natural processes that shape Earth. Along the way, we will pause to consider what traces might survive, what might vanish, and how humans fit into the much larger story of life on this planet. We will explore geology, climate, evolution, and archaeology. We will think about oceans that drowned coastlines, about ice ages that erased landscapes, about animals that once walked beside us, and about the possibility, however faint, that others may have walked this ground long before we arrived. For now, rest with this opening thought. Civilizations, even ours, are fragile in the face of time. The pyramids may seem eternal, but in the scale of millions of years, they too are fleeting. Our world, filled with light and sound, may fade into silence more quickly than we expect. And as we drift into that silence tonight, we begin the journey of asking, were we truly the first? When we think about memory, we often imagine the human brain, storing fragments of sound, image, and feeling. But the Earth also has memory, though it works on a very different scale. It does not remember voices or faces. Instead, it remembers through layers: stone, ice, sand, and fossils. These are its pages, written slowly, each line taking thousands or even millions of years to form. If we want to ask whether something came before us, whether there could have been civilizations hidden in the deep past, this is where we must look. Geologists call this record the stratigraphic column. Picture the Earth's crust as a library of stone. At the surface we find the youngest layers, rich with soils, modern sediments, and traces of today's life. Below them lie older layers, compacted sands that once were shorelines, limestones built from ancient coral reefs, and shales formed from quiet seafloor mud. As we dig deeper, we move further back in time. Each layer contains tiny clues. A fossilized leaf might suggest a warm climate. A ripple pattern in sandstone tells of shallow water. Volcanic ash can be dated precisely using isotopes, serving as a timestamp burned into rock. The deepest layers we have studied go back billions of years to a time when life itself was microscopic. Within those ancient rocks, geologists find stromatolites, layered structures made by bacteria. In younger rocks, they find shells, bones, and eventually footprints. Step by step, the library of Earth reveals its story. But it is an incomplete library. Pages are missing, torn out by erosion, recycled by tectonics, or buried beyond reach. Imagine for a moment if our civilization vanished and the Earth began to file us away. Some of our artifacts might settle into rivers, lakes, or shallow seas, where they could become buried under sediments. A collapsed bridge, rusting slowly, could be covered by silt. In 1,000,000 years, that bridge might be compressed into rock, leaving only distorted traces of its shape. A shard of glass could become embedded in sandstone. Fragments of plastic might survive longer, but even they would eventually break down, altered by chemical reactions and pressure. Most of our structures, our machines, and even our bones would be gone. Scientists have calculated how long different materials last. Concrete may endure for tens of thousands of years, but on the scale of millions, it too would crumble. Iron rusts quickly. Copper corrodes. Only certain ceramics, some alloys, and perhaps radioactive waste might persist long enough to be detected after tens of millions of years. Even then, they would be scattered and rare. To find them would require extraordinary luck. The Earth does not only bury, it also erases. Mountains rise through tectonic collision and are worn down by rain and wind. Rivers carve valleys, transporting sediments far away. Coastlines are swallowed by rising seas. Entire continents drift. Subduction zones pull crust into the mantle, recycling rock back into molten material. What once was surface becomes hidden deep beneath. In this endless cycle, almost nothing escapes. Consider the ocean floor. It may seem like a place where ancient history could be preserved, but in truth, the ocean crust is geologically young. Most of it is less than 200 million years old. New crust forms at mid-ocean ridges, while older crust is destroyed at trenches. This means that if a civilization had existed 300 million years ago, all traces on the seafloor would be gone. The library would have been rewritten entirely. Still, there are places where the Earth's memory is clearer. Ice cores from Greenland and Antarctica preserve climate records stretching back hundreds of thousands of years. Within the layers of ice, tiny bubbles of ancient air remain trapped, telling us about carbon dioxide, methane, and even volcanic eruptions. Sediment cores from lakes and oceans capture pollen, dust, and chemical traces. These records allow scientists to reconstruct not only climates, but also events, droughts, floods, and fires. If an industrial civilization had risen within the last 1,000,000 years, it might have left chemical fingerprints. unusual concentrations of carbon, artificial isotopes, or pollutants unlike any natural process. So far, we have not found such evidence. But what about deeper time, tens of millions of years ago? Here the trail becomes harder to follow. Rocks from those eras often show massive climate swings. Some were caused by natural forces, like volcanic outpourings or asteroid impacts. These events sometimes left signals that seem strangely artificial. A sudden rise in carbon dioxide, an unexpected spike in heavy metals, a rapid extinction of species. Could any of these have been caused by something other than nature? Most scientists would say no. Natural explanations, from giant eruptions to shifts in ocean chemistry, usually fit the data. Yet the fact remains that Earth's memory is imperfect. We see shadows, but not the full picture. One example often discussed is the Paleocene-Eocene thermal maximum, about 56 million years ago. During this event, global temperatures rose sharply, carbon dioxide surged, oceans warmed, and ecosystems changed dramatically. Some have wondered if this spike could represent industrial activity, but the more accepted explanation is that massive volcanic activity released methane and carbon. Even so, the idea highlights how difficult it is to separate natural and artificial signals in the deep past. Another challenge is erosion. Imagine a city built of stone on a floodplain millions of years ago. Over time, the river changes course, sweeping away walls, grinding stones into pebbles. Later, glaciers pass, scraping the surface down to bedrock. When the ice melts, new rivers form, carrying sediments far downstream. The original site disappears, erased as if it had never been. To detect it would be almost impossible. Only in very rare conditions, where rapid burial and low disturbance coincide, could traces survive. This is why archaeology deals mostly with the last tens of thousands of years. Beyond that, human remains and artifacts grow scarce. Fossils of hominins are rare even within 2 million years. Most of what we know about early humans comes from small fragments. A jawbone here, a skull fragment there, a handful of stone tools. These tiny signals are all that survived. If traces of our ancestors are so limited, how much harder would it be to find traces of a hypothetical earlier civilization millions of years older? Still, science does not close the door. Researchers sometimes ask what sort of evidence we might expect. Artificial isotopes, like plutonium-244, do not occur naturally in large amounts. If discovered in ancient rocks, they would raise questions. Similarly, certain manufactured compounds, such as specific plastics or chlorofluorocarbons, would be strong markers. Yet so far, none have been identified in deep-time geology. The absence of such markers supports the view that we are the first global technological civilization. But the possibility, however slim, continues to invite curiosity. To help imagine this, think of Earth as a palimpsest, a manuscript that has been written, erased, and written again. Traces of earlier writing may remain faintly visible, but only if one looks closely and under the right conditions. The Earth's crust works in much the same way. Some pages are clear, others are smudged, and many have been scraped clean. Our task, as observers, is to read what remains while accepting that much has been lost. And so the question becomes not only whether another civilization existed, but also whether the Earth could even preserve the memory of such a thing. The answer, based on geology, is that preservation is unlikely. Time is a relentless editor, cutting, overwriting, and recycling. What we see today is only a fraction of the planet's story. Yet perhaps that is what makes the question compelling. The gaps themselves invite imagination. In missing layers, in unexplained shifts, in vanished worlds, there is room for wondering. Science reminds us to be cautious, but also to stay curious. Because curiosity does not replace evidence, it prepares us to recognize it should it appear. As you rest, imagine the slow turning of Earth's pages. Picture strata laid down quietly, grains of sand settling into patterns, fossils embedded as silent witnesses, ice recording the breath of ancient atmospheres. This is how the planet remembers. And in these memories, we seek answers, not only about our past, but about whether we are truly alone in being the first. In the next part, we will look more closely at how catastrophes, ice ages, floods, volcanic eruptions and impacts have shaped this memory, erasing some chapters entirely. For if civilizations did exist before us, it may have been these catastrophes that wiped them away. When we think of history, we often imagine a long chain of continuity. One era flows into the next, people build upon what came before, and progress appears steady. But the Earth does not always allow such smooth transitions. It interrupts, it resets, and sometimes it erases almost everything. To understand how civilizations, if they ever existed before us, could vanish, we must look at the role of catastrophes. These are the forces that reshape the surface, reset ecosystems, and leave gaps in the planet's memory. The most familiar of these interruptions are ice ages. Over the last 2.5 million years, the Earth has cycled repeatedly through glacial and interglacial phases. Vast sheets of ice, sometimes more than a mile thick, advanced over continents. They ground down mountains, carved valleys, and buried entire regions under silence and cold. When the glaciers retreated, they left behind scoured landscapes, new lakes, and rearranged rivers. In North America, the Great Lakes are remnants of this process. In Europe, valleys and fjords trace the paths of ice. For anything built before these events, survival would be doubtful. Cities, fields, or roads would have been ground away. The ice did not preserve, it obliterated. These cycles were driven by changes in the Earth's orbit, known as Milankovitch cycles. Slight shifts in tilt, wobble, and orbit changed the amount of solar energy the planet received. This triggered advances and retreats of ice sheets over spans of tens of thousands of years. In the human timescale, these were overwhelming forces, far beyond control. If civilizations had existed in the path of advancing glaciers, their traces would have been reduced to rubble and sand. Even now, we can only reconstruct glacial periods through indirect evidence. Striations on rocks, deposits of till, layers of ice containing trapped gases. The human eye sees only the aftermath. Another powerful agent of forgetting is sudden climate change. Around 12,900 years ago, as the last ice age was ending, the planet abruptly cooled again in an event called the Younger Dryas. For more than 1,000 years, glaciers stopped retreating and climates shifted back toward colder, harsher conditions. The exact cause is still debated. Some suggest a massive outflow of fresh water into the North Atlantic, disrupting ocean circulation. Others point to possible impacts or volcanic activity. Whatever the cause, the effect was dramatic. Megafauna such as mammoths, mastodons, and giant ground sloths disappeared in many regions. Human populations adapted, changed their tools, and shifted their ways of living. For a moment, pause to picture those landscapes. Herds of mammoths moving seasonally across open plains, seeking fresh grasses as glaciers melted. Groups of bison grazing in enormous numbers, shaping the land as they travelled. Saber-toothed cats, not in constant pursuit as fiction often portrays, but conserving energy, ambushing prey at just the right moment. These were ecosystems in balance, complex and dynamic. But with the rapid climate swing of the Younger Dryas, much of this balance collapsed, species vanished, and human communities faced new challenges. If small civilizations had begun to form during the warming period before this cold snap, many could have been disrupted or erased. Volcanoes provide another path to forgetting. A single eruption can bury entire regions. In 79 CE, Mount Vesuvius covered Pompeii and Herculaneum under ash, preserving them for us to rediscover. But in deep time, most eruptions do not preserve, they destroy. Ash can blanket hundreds of kilometres, killing plants and animals, collapsing roofs, and altering climates. On a larger scale, massive volcanic outpourings, known as flood basalts, can release vast amounts of gas and particles into the atmosphere. These events have triggered mass extinctions in the past. The Siberian traps, around 252 million years ago, poured out so much lava and gas that nearly all life on Earth was threatened. If any civilization had existed during such an event, its traces would have been buried under kilometres of basalt. Detecting even a fragment would be nearly impossible. Asteroid impacts represent perhaps the most absolute form of erasure. 66 million years ago, a space rock struck near present-day Yucatan, creating the Chicxulub crater. The energy released was equivalent to billions of atomic bombs. The skies darkened, fires raged, and most of the dinosaurs perished. Layers of iridium-rich clay still mark this boundary in geology. Impacts of this scale do more than destroy. They reset ecosystems entirely. In the aftermath, new groups of animals, including mammals, expanded into niches left vacant. If advanced life had existed before, its remains would have been incinerated or buried beneath the ejecta. The memory of its existence would have been reduced to dust. Yet catastrophes need not be global to erase civilizations. Floods, earthquakes, and regional droughts can end societies as well. Around 400 years ago, a severe drought affected many parts of the world. The Akkadian Empire in Mesopotamia collapsed, Egyptian society faced upheaval, and the Indus Valley civilization began its decline. These were not technological collapses, but ecological ones. Crops failed, rivers shifted, and populations scattered. Even when people survived, their cities did not. Archaeologists find layers of abandonment, silence where once there was trade and life. If such collapses happened repeatedly in deeper time, their traces would be even more fragile. All of these forces, ice, climate, volcanoes, impacts and drought, share one thing in common. They leave gaps, they interrupt continuity, they turn thriving ecosystems and societies into silence. From the perspective of sleep, as you listen now, imagine those silences not as sudden explosions of drama, but as long, quiet absences. Imagine valleys covered by ice for thousands of years, erasing what lay beneath. Imagine forests regrowing over abandoned plains, roots breaking apart walls, stone by stone. Imagine lava flowing steadily for centuries, burying landscapes layer by layer until they became unrecognizable. The earth forgets not through sudden disappearance alone, but through slow, relentless change. And yet, these catastrophes also set the stage for renewal. The retreat of glaciers opened new lands for plants and animals. The extinction of large reptiles allowed mammals to expand. The disruption of ecosystems created opportunities for new adaptations. Humans, too, thrived not in spite of catastrophe, but often because of it. Our species spread widely during unstable climates, adapting to changing conditions, learning flexibility. In this sense, catastrophe is not only an eraser, but also a teacher. But what does this mean for the question of civilizations before ours? It means that if any had existed, even briefly, catastrophes would have been merciless editors. The odds of survival for fragile artifacts, fragile buildings, or fragile knowledge are extremely low. Stone and bone vanish under glaciers. Metal corrodes in floods. Wood burns in volcanic ash. Entire continents shift under tectonic plates. The Earth, while recording much, is not generous with delicate memories. This perspective reminds us of our own fragility. Though our world feels stable, we too live under the same conditions. We know that future ice ages will come, that volcanoes will erupt, and that impacts, though rare, remain possible. Our cities may seem secure, but in the long rhythms of geology, they are temporary. It is not difficult to imagine a future where only faint traces remain of us, buried in rock layers or lost entirely. To future eyes, our time might appear as a thin, ambiguous line, much like those we struggle to interpret today. Still, catastrophes are not absolute in their silence. Sometimes they preserve. Ash buried Pompeii, but also protected it. Ice can grind down landscapes, but also trap remains in frozen vaults. Impacts obliterate, yet they also leave a global chemical fingerprint, as with iridium. This duality is important. It means that even amid destruction, fragments may persist. And if fragments could persist for us, perhaps they could for others, should others have existed. As we move forward in this exploration, keep in mind how fragile survival is. For humans of the Ice Age, survival meant adapting to glaciers and changing prey. For Megafauna, it meant adjusting migrations, herds, and strategies. Some succeeded, others did not. The Earth kept changing, indifferent to the outcomes. If there were civilizations long before us, they too would have faced these same indifferent forces. Their survival would have been precarious, their memory in stone almost impossible. The next chapter in our journey will turn more directly to those Ice Age landscapes themselves. The megafauna, the humans, and the ecological balances they lived within. For it is here, in the Pleistocene world, that we find both mystery and possibility. And if we listen closely, perhaps we can hear echoes of what might have been. As the last Ice Age unfolded, the world was home to animals that no longer walk beside us. To imagine these landscapes is to step into a quieter, colder Earth. Forests, grasslands and tundra stretched across continents, shaped by the rhythm of glaciers advancing and retreating. Within these habitats lived creatures of immense size, giant mammals that scientists call Megafauna. Mammoths, mastodons, giant bison, saber-toothed cats, and ground sloths were part of ecosystems far different from the ones we know today. Understanding their world helps us understand our own, because it was within these landscapes that humans adapted, survived, and began to flourish. Picture the northern plains of Eurasia during a glacial period. The land is open, with patches of hardy grasses and shrubs. The air is crisp, sometimes biting, but life endures. A herd of woolly mammoths moves across the steppe, their long hair rippling in the wind, their tusks curving forward like ivory crescents. They walk slowly but steadily, covering long distances as they seek fresh pastures. These animals were not solitary giants, but social beings. They travelled in groups, led by matriarchs who remembered routes to food and water. Young mammoths followed close, learning as they went. Seasonal migration defined their existence, much as it does for elephants today. Nearby, other species carved out their roles. Herds of steppe bison grazed in large numbers, shaping the vegetation as they moved. Predators adapted to this abundance. Saber-toothed cats, with their long, curved canine teeth, waited in cover, conserving energy until the moment to strike arrived. Contrary to their fierce appearance, they were not reckless hunters. Their survival depended on patience, on timing, on conserving strength in an unforgiving environment. Cave lions prowled the edges of valleys, hunting in groups, while wolves followed the herds, opportunistic and adaptable. Into this intricate balance entered humans. For hundreds of thousands of years, hominins had lived across Africa, Asia, and Europe. Homo erectus used tools, Neanderthals created art and buried their dead, Denisovans left genetic traces in modern populations. But by the late Pleistocene, Homo sapiens began to spread more widely. Carrying new forms of stone blades, symbolic art, and complex language, they moved into landscapes filled with megafauna. The meeting of humans and these giant animals was not sudden, but gradual, shaped by climate, opportunity, and adaptation. Evidence shows that humans hunted some of these large animals. Spear tips, stone blades, and butchery marks on bones tell us that mammoths and bison were part of human diets. Yet hunting was not constant slaughter. These animals were dangerous, and humans were cautious. Much of the relationship was one of observation, tracking herds, waiting for opportunities, using knowledge of migration to survive. Fire allowed humans to cook meat and manage landscapes, creating open areas where animals could graze. Clothing made from hides gave protection against cold, and shelters built from mammoth bones and tusks reveal how closely intertwined human survival was with megafauna. But these interactions carried consequences. As climates shifted at the end of the Ice Age, many megafaunal species declined. Warming melted glaciers, forests spread, and open grassland shrank. Food sources changed, migration routes shifted, and habitats disappeared. For animals already under stress, human hunting may have added the final pressure. The extinction of mammoths, mastodons, giant sloths, and saber-toothed cats was not caused by a single factor, but by the combination of climate and human expansion. What resulted was a transformed world, where humans became the dominant force in ecosystems. This transformation is critical to the puzzle of civilization. For if we ask whether earlier advanced societies might have existed, we must also ask how they would have interacted with their environment. Ecosystems leave records, not only in fossils, but in patterns of extinction and survival. When we study the end of the Pleistocene, we see the fingerprints of human influence, shifts in animal populations, spread of fire use, and expansion of settlements. If another civilization had existed earlier, we might expect similar ecological disturbances. Yet so far, the evidence of such disturbances points to natural cycles and, later, to the rise of Homo sapiens. Still, the Pleistocene world was rich with mystery. In Siberia, frozen remains of mammoths have been discovered, their bodies preserved in permafrost for tens of thousands of years. Some still hold traces of grass in their mouths, caught at the moment of sudden freezing. In North America, tar pits have captured the bones of dire wolves, saber-toothed cats, and bison, preserving them in dark pools that reveal the abundance of life long gone. These remains give us glimpses into behaviours, herding, hunting, struggling, that define ecological balance. They are reminders that the world we know today is only one version of Earth's possibilities. Humans, for their part, left increasing traces in these landscapes. Caves bear paintings of animals, drawn with calm attention to detail. Hands pressed onto walls leave marks that feel like signatures across time. Tools grew more varied. Scrapers for hides, awls for sewing, blades for hunting. Burial sites show care for the dead, with ochre, ornaments, and sometimes flowers placed beside bodies. These traces suggest not only survival, but culture, patterns of thought, memory, and meaning. From such foundations, civilizations would later emerge. But in the Ice Age world, survival still depended heavily on the cycles of climate and the rhythms of megafauna. One might wonder, what if humans had not succeeded in this balance? What if the climate had shifted differently, or if predators had remained more dominant? Would the story of civilization have unfolded another way? These questions remind us how contingent history is, shaped by chance as much as by adaptation. It is possible to imagine worlds where humans remained a minor presence, or where other species carried forward in ways we cannot fully picture. The evidence we have, however, shows that humans became increasingly central to ecosystems, while many megafauna receded into extinction. This shift carries lessons for our broader question about civilizations before us. If advanced societies had emerged tens of thousands or millions of years ago, their influence on ecosystems would likely have been visible. Species might have declined earlier, forests might have been altered, or chemical signatures might appear in sediments. Yet what we see is the gradual, natural rhythm of climate and the specific, recognizable impact of late Pleistocene humans. No earlier fingerprints have been found. Still, this does not diminish the awe of what did exist. The Pleistocene was a world alive with complexity. Mammoths following ancient paths remembered across generations. Bison shaping grasslands with their constant grazing. Predators adapting their strategies to survive in lean winters. Humans observing, learning, and slowly altering the balance. Together, these forces created a dynamic world that prepared the stage for what came next. As you rest, imagine lying quietly in an Ice Age shelter, perhaps a simple structure of wood and bone, warmed by a fire. Outside, the muffled sounds of animals carry across the frozen steppe. A mammoth herd moves slowly in the distance, their silhouettes fading into the snowy horizon. Wolves howl faintly, their calls echoing through the night. For early humans, these were the sounds of survival, the background to every decision and every dream. It was within this world of megafauna and climate uncertainty that the seeds of civilization were planted. The human puzzle is not only about what we built, but about how we fit into ecosystems, how we adapted, and how we learned from the animals around us. The disappearance of megafauna changed the balance permanently. It opened niches, forced new strategies, and altered landscapes. From this turning point, human societies began to expand more widely, to farm, to settle, and eventually to build the structures we now call civilization. In our search for lost histories, it is tempting to imagine grand civilizations long before ours. But when we listen closely to the record of the Pleistocene, what we hear is a quieter story. One of adaptation, of coexistence with animals now gone, of survival within fragile balances. If there were earlier civilizations, they left no echoes here. What we do find are the traces of our own beginnings, intertwined with the last days of mammoths, bison, and saber-toothed cats. In the next part of this journey, we will turn to the anomalies of archaeology, the sites and artifacts that puzzle researchers, the structures and objects that seem out of place, and the debates they spark. For while the Pleistocene shows us balance and extinction, the archaeological record sometimes presents mysteries. And it is within these mysteries that curiosity about lost civilizations often takes root. As humans began to step out of the Ice Age, they carried with them not only survival skills, but also memory, imagination, and creativity. It was in this period, after thousands of years of adapting to glaciers, megafauna, and shifting climates, that we see the beginnings of what we call civilization. But archaeology, the science of uncovering this past, does not always present a neat, continuous story. Sometimes it reveals puzzles, anomalies that seem to challenge our understanding of when and how human societies began to build, farm, and organize. These are the anomalies that stir curiosity, that make some people wonder whether we might be missing entire chapters of history. One of the most striking examples is Göbekli Tepe in southeastern Turkey. Discovered in the 1990s, this site consists of massive stone pillars arranged in circular enclosures, some weighing more than 10 tons. The stones are decorated with carvings of animals, foxes, snakes, wild boars, and birds, rendered with striking clarity. What makes Göbekli Tepe so remarkable is its age. Radiocarbon dating places its construction around 11,000 years ago, thousands of years before the pyramids of Egypt or the ziggurats of Mesopotamia. At a time when most humans were still living in small groups of hunters and gatherers, this site suggests large-scale organisation, shared ritual, and advanced knowledge of construction. To put this in perspective, consider daily life at that time. People had not yet widely adopted farming. They lived in mobile bands, following game and gathering plants. Tools were made of flint, shelters were temporary, and clothing came from hides. Yet here, on a hilltop in Anatolia, humans gathered to shape stone on a monumental scale. Why did they do this? Was it for religion, community, or some other purpose we can only guess? Whatever the reason, it demonstrates that complexity, cooperation, and imagination were present far earlier than once believed. Sites like Göbekli Tepe remind us that human history is not always a straight line. Agriculture, cities, and writing did not appear everywhere at once. Instead, they arose in scattered places, sometimes earlier than expected, sometimes later. The discovery of early monumental structures forces us to reconsider the limits of what was possible in different times. It does not prove the existence of lost civilizations before the known ones, but it shows that human societies were capable of remarkable achievements long before the traditional milestones of civilization. Another puzzle lies in artifacts that appear out of place. Over the years, reports have surfaced of objects found in geological layers that seem too old for their design. These so-called out-of-place artifacts include claims of advanced tools or manufactured items embedded in rock or coal. Most of these cases turn out to be errors of context, misinterpretations, or outright hoaxes. Yet even when explained, they serve to remind us how fragile the archaeological record is. Small anomalies can spark large questions, especially when the broader picture is incomplete. Take, for instance, the Antikythera mechanism, discovered in a shipwreck off Greece in the early 20th century. At first, it looked like a corroded lump of bronze, but closer study revealed an astonishingly complex system of gears, capable of modelling the movements of the sun, moon, and planets. It dates to around 2,000 years ago, within the Hellenistic period. While it is not evidence of an earlier civilization, it is a reminder of how much knowledge can be hidden, forgotten, or underestimated. If the mechanism had not been preserved underwater, we might never have known that such mechanical sophistication existed in antiquity. Daily life in early agricultural communities also offers its own mysteries. Around 9,000 years ago, in places like Jericho and Çatalhöyük, people began to settle in permanent houses. They grew grains, kept animals, and stored food. These were not cities in the modern sense, but they were stable communities with art, ritual, and architecture. Murals show leopards, vultures, and geometric designs. Figurines depict human forms, sometimes interpreted as deities, sometimes as symbols of fertility. These communities remind us that the line between civilization and pre-civilization is blurred. Complexity grew in layers, and traces of it appear earlier than we once thought. Astronomical alignments also fuel curiosity. Many ancient structures, from Stonehenge in Britain to the pyramids in Egypt to the temples of Central America, align with solstices, equinoxes, or star positions. Such alignments reveal careful observation of the sky, a practice rooted in survival. Knowing when seasons changed meant knowing when to plant or harvest. Watching the heavens connected people to cycles larger than themselves. For some, the precision of these alignments suggests knowledge that should not have existed. For archaeologists, it reflects the patience and observational skills of people who lived closely with natural rhythms. When nights were dark and skies were clear, the stars were both calendar and compass. It is worth pausing to imagine how these discoveries felt to those who first made them. A group of early farmers in Mesopotamia watching the river rise and fall, learning the rhythm of floods. A circle of people in Britain watching the sunrise between stones at the solstice, marking the longest day of the year. A community in Mesoamerica carving temples that caught the shadow of the sun in precise ways. These were not mysteries to them, but tools, ways of living within the cycles of earth and sky. Yet for us, looking back, they feel almost like messages from another world. The anomalies of archaeology are not evidence of lost civilizations in the distant past. Instead, they are reminders of how resilient, inventive, and surprising humans can be. They show that complexity arises earlier and in more varied forms than we once assumed. They also remind us that much has been lost. For every Göbekli Tepe, there may be countless sites buried, eroded, or submerged. For every Antikythera mechanism, there may be dozens of inventions that never survived. The archaeological record is a thin thread, and we follow it with care. Some anomalies may never be fully explained. A carving whose meaning is lost. A structure whose purpose we cannot reconstruct. A tool that seems advanced for its time. These puzzles are not failures of science, but part of its ongoing process. Each question invites further study, new methods, and deeper patience. And in the quiet of night, they invite us to wonder, what else might be waiting beneath the soil, beneath the waves, or in the layers of stone? As you rest, imagine the hands of those early builders, calloused from shaping stone, steady as they carved animals into pillars, precise as they set massive blocks upright. Imagine the farmers bending over fields of barley, the shepherds guiding flocks, the artisans carving figurines. Life was slower, quieter, but filled with meaning. Their world was not primitive, it was simply different, shaped by needs and rhythms we can still recognize. In the next part of our journey, we will turn to the oceans. Because when the Ice Age ended, sea levels rose dramatically, drowning coastlines and perhaps entire settlements. If there are hidden chapters of human history, many of them may now lie underwater, silent and unseen. When the last Ice Age ended, the world didn't simply warm, it changed shape. Glaciers melted, seas rose, and coastlines shifted dramatically. Places that were once dry land became seabeds, while islands appeared where there had been mountains. For early humans, these changes were not abstract, they were lived realities. Camps, villages, and pathways that once stood on solid ground disappeared beneath rising water. If civilizations had left traces in these drowned landscapes, the ocean has covered them with silence. To understand this, we must recall how much water was locked in ice at the peak of the last glaciation, around 20,000 years ago. Sea levels then were about 120 metres lower than today. Vast areas of land, now submerged, were exposed, connecting continents and creating rich environments for life. The British Isles were connected to mainland Europe. Siberia and Alaska formed a single bridge of land known as Beringia. Southeast Asia stretched into a broad subcontinent called Sundaland. These were not marginal zones, but central habitats filled with rivers, forests, and grasslands where humans and animals thrived. Doggerland is one of the clearest examples. Today, the North Sea separates Britain from Europe, its floor hidden beneath waves. But during the Ice Age, Doggerland was a vast plain, stretching from what is now the Netherlands to the eastern coast of Britain. Archaeological evidence shows that people lived there. Stone tools, animal bones, and even traces of settlements have been recovered by fishermen and researchers. For thousands of years, this was a fertile land of rivers and marshes, rich in game and plants. As the climate warmed and seas rose, Doggerland gradually shrank, until finally only the islands and hills remained above water. By around 8,000 years ago, it had vanished entirely beneath the sea. The story is similar in Beringia. This land bridge connected Asia and North America, providing a corridor for animals and humans to move between continents. For millennia, it supported herds of bison, mammoths, and reindeer. Human groups crossed and settled, carrying tools and traditions. When the ice melted and seas rose, Beringia disappeared, leaving only the strait that separates Russia from Alaska today. What remains of those ancient crossings is now submerged, hidden under cold waters. In Southeast Asia, Sundaland once stretched across what is now Indonesia, Malaysia, and surrounding seas. Vast river systems drained into a central basin, creating fertile lands. As seas rose, lowlands were swallowed, leaving behind the scattered islands of today's archipelago. Myths and stories from these regions sometimes speak of lands lost to the sea, echoes of a memory carried forward by oral tradition. While such stories cannot be taken as direct evidence, they remind us how profoundly rising waters shaped human life. Consider how rising seas would have appeared to those living through it. The change was slow on the scale of a lifetime, perhaps a few centimetres per year, but relentless. Camps once near a riverbank became marsh, then shallow bay, then sea. Villages had to move inland again and again. To those living then, the ocean may have seemed like a living force, always encroaching, always taking more. Over generations, memories of lost lands became part of cultural identity, told as stories of floods and vanished worlds. This has important implications for the question of hidden civilizations. If early societies had built along coasts, and it is natural that they would, since coasts provide food, transport, and moderate climates, then many of their remains now lie underwater. Archaeologists estimate that up to 90% of early human settlements may be submerged today. This does not mean advanced civilizations were lost, but it does mean that a vast portion of our early history is inaccessible. The ocean floor conceals it beneath layers of sediment, currents, and salt. Underwater archaeology is still young. Divers and sonar surveys have revealed shipwrecks, harbours, and even stone structures in shallow seas. But the vast majority of the seafloor is unexplored. It is difficult, expensive, and dangerous to search. Sediment covers artifacts, currents move materials, and visibility is limited. Only in recent decades have technologies like submersibles and seabed mapping allowed us to look more closely. Even so, What we have seen is a fraction of what lies below. Some discoveries hint at what might remain hidden. Off the coast of India, near the Gulf of Khambhat, sonar surveys have revealed structures interpreted by some as ancient city remains. Debate continues, with many archaeologists cautious about drawing conclusions. In Japan, the Yonaguni Monument consists of massive stone formations beneath the sea, shaped in ways that some claim are artificial. Most geologists interpret it as natural erosion, yet the debate continues. These sites capture imagination because they raise the possibility, however faint, that we have overlooked early coastal settlements. It is worth pausing here. For those listening as they rest, picture the slow transformation of coastlines. Imagine a fishing camp on the shore of Doggerland. Nets drying in the wind, children gathering shells, smoke rising from a hearth. Over years, the shoreline creeps closer. A marsh forms where fields once stood. Generations later, the sea covers the camp entirely. To those people, the sea was not abstract. It was a patient force, claiming land step by step. Multiply this story across thousands of years, across Beringia, Sunderland, and countless smaller coasts, and it becomes clear how much history is now hidden beneath waves. Silence of the oceans is not only physical, but also symbolic. We look to land for our history because land is accessible. We dig into soil, uncover bones and pottery, trace patterns of settlement. But the oceans, vast and deep, guard their secrets. What lies beneath may remain unknown, not because it never existed, but because we cannot reach it. This silence is part of the reason questions about lost civilizations persist. We know so little of what the oceans conceal that imagination fills the gaps. Still, science urges caution. Most submerged structures studied so far have natural explanations. Sediment patterns, coral growth, and erosion can mimic human shapes. True artifacts are rare, and even when found, they are often fragile. The absence of clear evidence supports the view that large-scale civilizations before known history are unlikely. Yet the scale of what is hidden means we must also admit that absence is not proof. Silence can be both emptiness and concealment. As we rest with this thought, it is helpful to remember that the sea is not only a destroyer of memory, it can also preserve. In anaerobic, waterlogged conditions, organic materials sometimes survive for thousands of years. Wooden tools, textiles, and even seeds have been found in submerged sites where oxygen was absent. In rare cases, the sea becomes not only a barrier, but also a vault, protecting what would otherwise decay. The balance between destruction and preservation is delicate, and much depends on chance. The ocean's silence, then, is not absolute. It is a mixture of loss and possibility. We may never know the full extent of what lies beneath, but the very act of searching reminds us how much of Earth's story remains unwritten. For our ancestors, the rising seas were a challenge to survival. For us, they are a challenge to memory. As you listen, imagine drifting on a calm sea at night. Beneath you lies a hidden landscape, rivers now silent, forests now buried, paths once walked by human feet. The waves move gently above, concealing all that is below. It is a reminder that history is never complete, that what we know is always less than what has been. In the next part, we will return to land, to the civilizations we know that rose and fell. Their ruins stand as visible reminders that societies can vanish, leaving behind silence not unlike that of the ocean. By studying these known collapses, we can better understand how fragile civilizations may be, and how easily they could be forgotten. When we speak of lost civilizations, the imagination often leaps to legends, Atlantis sinking beneath the sea, cities swallowed by the desert, or empires destroyed overnight. But the truth is quieter, slower, and more revealing. Civilizations do not vanish in a single dramatic moment. They fade, fragment, and transform. Their people adapt, migrate, and continue in new forms. Yet the cities, the monuments, and the systems they built often collapse under pressures they cannot withstand. By studying these known collapses, we begin to see how fragile civilizations truly are, and how easily they can slip into silence. One of the earliest examples comes from Mesopotamia, the so-called cradle of civilization. Around 4,200 years ago, the Akkadian Empire rose to prominence under the leadership of Sargon of Akkad. It was the first large empire in recorded history, stretching across much of Mesopotamia and uniting diverse peoples. For a time, it seemed stable and powerful. Yet within a few generations it faltered. Archaeological evidence points to a severe drought that lasted more than a century. Crops failed, rivers dwindled, and famine spread. Without food, the empire's structure collapsed. Cities were abandoned, and nomadic groups moved into weakened territories. What had seemed strong proved fragile against the power of climate. The Akkadian Empire became a memory, preserved only in fragmented texts and scattered ruins. Farther east, in the Indus Valley, another great civilization thrived between 2600 and 1900 BCE. Known today as the Harappan, or Indus Valley Civilization, it built carefully planned cities like Mohenjo-Daro and Harappa. Streets followed grids, drainage systems carried waste, and standardized weights suggest organized trade. Yet by 1900 BCE, these cities were in decline. Archaeologists see signs of drought, shifting river courses, and overuse of land. The Saraswati River, once a major waterway, may have dried or changed its path. Without stable water supplies, agriculture faltered. Populations dispersed into smaller villages. Unlike Mesopotamia or Egypt, the Indus left no grand temples or monumental inscriptions, and their script remains undeciphered. What remains are bricks, artifacts, and unanswered questions. A civilization that had once flourished with order and stability became scattered fragments. In Mesoamerica, the story of the Maya illustrates another form of collapse. At their height, Maya cities like Tikal, Palenque, and Copan were centers of astronomy, writing, and architecture. They built pyramids, carved stelae, and tracked the movements of planets with remarkable precision. Yet around the 9th century CE, many major Maya cities in the southern lowlands were abandoned. Evidence suggests prolonged droughts combined with deforestation and soil depletion. As agriculture failed, cities could no longer support large populations. Warfare and political stress may have compounded the crisis. Yet the Maya did not vanish entirely. Descendants still live across the region, speaking related languages and maintaining traditions. The civilization collapsed in its urban form, but the people endured. Other examples are scattered across history. The Hittites of Anatolia, who rivaled Egypt in power, declined after internal strife and invasions. The Minoans of Crete, once vibrant traders in the Mediterranean, suffered from earthquakes and volcanic eruptions, particularly the eruption of Ferra around 1600 BCE. In South America, the great city of Tiwanaku near Lake Titicaca fell into decline after droughts weakened its agricultural base. In North America, the Mississippian culture, with its large earth mounds at Cahokia, reached a peak around 1100 CE, then declined within centuries, perhaps due to overpopulation, resource stress, and climate variability. What unites these stories is not mystery but vulnerability. civilizations, no matter how advanced, depend on stable environments. Water supplies, fertile soil, forests, and predictable climates are the foundations of urban life. When these foundations are disrupted by drought, flood, deforestation, or disease, complex societies struggle to adapt. Sometimes they recover. Sometimes they transform into smaller, more decentralized forms. And sometimes they dissolve entirely, leaving only ruins for later generations to uncover. Consider the human perspective of such a collapse. For a farmer in the Indus Valley, the decline may have meant fields drying up year after year, harvests shrinking, and neighbours moving away. For a scribe in Akkad, it may have meant recording dwindling grain supplies and watching temples lose influence. For a Maya priest, it may have meant seeing ceremonies fail to bring rain while people questioned old beliefs. These were not sudden catastrophes, but lived experiences, slow and uncertain, filled with hope one season and despair the next. From within, collapse felt like everyday struggle, not legend. Archaeology shows us that when civilizations fell, they left behind both traces and absences. We find broken walls, pottery shards, and scattered graves. We see sudden gaps in occupation layers, where once there were thriving cities. We detect chemical changes in soils that reveal overuse or drought. These traces are not dramatic in themselves. They are quiet, like the faint outlines of a story written in sand. Yet together, they reveal patterns. They show how societies rise, peak, and decline, often more than once. Collapse is not the end of humanity, but the end of a particular form of organisation. For our broader question, whether civilizations before ours might have existed, these stories provide a caution. If known civilizations with writing, monuments, and trade networks could fade into near silence within a few centuries, how much more easily could earlier ones vanish without leaving clear evidence? If the Indus Valley left us bricks and streets but almost no decipherable texts, how would we recognise a civilization millions of years older? The fragility of memory, even on scales of a few thousand years, highlights how quickly the Earth can forget. Still, there is a difference between disappearance and erasure. The Maya still live in Central America, the descendants of the Harappans farm in South Asia. The Akkadian language influenced later tongues. The cultural threads continue even when cities fall. This is important to remember. Civilizations transform. They do not vanish completely. The people endure even if the monuments crumble. If earlier civilizations existed in deep time, their descendants may not be visible, because species themselves change, evolve, and vanish. On the scale of millions of years, continuity is harder to trace. As you rest, picture walking through a ruined city long after its people have gone. The walls are broken, plants grow between the stones, and silence replaces the noise of markets. Yet the layout of streets hints at former life. The outlines of houses suggest families once lived here. A piece of pottery reveals a pattern, a design someone once cared about. These fragments are all that remain. They whisper of a world that once was, now quiet. The vanishing of civilizations also teaches humility. Our own world feels stable, but it too relies on fragile foundations: climate, soil, water, and cooperation. In the quiet of night, it is sobering to realise that the ruins we study were once as alive as our cities are today. Their decline was not inevitable, yet it came. The lesson is not fear but perspective. Civilizations, like living beings, are temporary arrangements in a changing world. In the next part of our journey, we will turn to a different kind of evidence. Not the ruins of cities, but the traces of technology and material culture. We will ask what kinds of markers truly last. and whether anything we build today could endure long enough to be recognised millions of years in the future. For if we wonder whether others came before us, we must also ask, what traces will we ourselves leave behind? When we ask what civilizations leave behind, it is tempting to think of monuments, pyramids, temples, walls and statues. These are the visible legacies of human ingenuity, the markers we visit in museums and archaeological sites. But when viewed through the lens of deep time, monuments are fragile. The question of traces is more subtle. What truly lasts? What disappears quickly? And if an advanced society had risen before ours, what markers might still remain? To answer this, it helps to look first at what past civilizations have left us. The pyramids of Egypt, more than 4,000 years old, still rise above the desert, their shapes weathered but unmistakable. Roman aqueducts still arch across valleys, their stones locked in place by gravity and design. Roads built by Rome can still be walked upon, yet beyond a few thousand years, most structures do not endure. Mesopotamian cities built from mud brick have mostly dissolved back into earth. Wooden buildings rot, iron tools rust, and textiles decay. Without careful burial or special conditions, artifacts vanish into dust. Archaeologists know this fragility well. They often find only fragments, pottery shards, stone tools, or the impressions of structures long gone. Pottery endures because it is baked, hardened by fire into ceramic that resists decay. Stone survives because it is already part of geology, but most of what humans create disappears quickly. Even in cities that thrived for centuries, we often recover only traces, a scatter of bones, a layer of ash, a few walls preserved by chance. Now, consider our modern world. Concrete, steel, glass, plastic and electronics seem stronger, more advanced. But how would they fare across tens of thousands, or millions of years? Concrete crumbles underwater and cracks in cycles of freezing and thawing. Steel corrodes, sometimes within decades. Glass fractures, and though shards may endure, they weather into sand. Plastics resist decay longer, yet even they degrade under sunlight, breaking into smaller particles. Electronics, so central to our lives, are perhaps the most fragile of all. Thin wires, delicate circuits, and complex components that crumble rapidly outside controlled environments. If humanity vanished tomorrow, cities would begin to erode within decades. Skyscrapers, once symbols of permanence, would rust and fall. Within a few thousand years, forests would reclaim much of the land, rivers would cut through concrete, and shifting soils would bury what remained. In 50,000 years, only stubborn fragments, ceramics, plastics, or traces of altered soil chemistry might survive. In 1,000,000 years, even these would be rare. Geological processes would recycle, bury, or erode them. The traces of an entire global civilization might be reduced to a few ambiguous signals. Scientists sometimes speculate about what markers might truly endure. Radioactive isotopes are one example. Nuclear testing and power generation create isotopes not found naturally in significant amounts. Plutonium-2 or 4, with a half-life of 80 million years, could linger in rocks. Future geologists, if they existed, might detect a sudden spike in such isotopes and wonder about their origin. Similarly, synthetic chemicals like certain plastics or fluorocarbons might leave faint signals. Some metals, if alloyed in unusual ways, might persist longer than pure forms. These would not appear as intact artifacts, but as chemical anomalies in sediments. Fossilization offers another possibility. Under rare conditions, organic material is replaced by minerals, preserving shapes in stone. If a car or building were buried quickly under the right conditions, some outline might fossilise. Yet such preservation is extraordinarily unlikely. Fossilisation favours bones, shells and plants, not complex machines. The odds of future scientists finding a fossilised airplane are vanishingly small. Far more likely would be the survival of simple, durable fragments. This helps us imagine the challenge of detecting earlier civilizations. If another society had risen millions of years ago, what traces would it have left? We would not expect intact cities or machines. Instead, we might find unusual isotopes, layers of ash with chemical anomalies, or sudden shifts in fossil records. These are precisely the kinds of signals scientists study in geology. So far, none have been found that clearly suggest an artificial origin. This absence supports the view that we are the first technological civilization on Earth. Yet the very difficulty of detection means we cannot be entirely certain. To bring this closer to daily life, imagine New York City without people. Within a few years, windows shatter, plants push through cracks, and animals move in. Within centuries, bridges collapse, subways flood, and buildings crumble. Within millennia, sediments cover the ruins, and only faint traces remain. A geologist millions of years later might drill a core and find a thin layer of unusual chemistry, perhaps higher levels of metals, plastics, or isotopes. To them, it might look like a strange, brief event, not a thriving civilization of billions. The scale of time makes even the most extraordinary cultures seem like passing shadows. There are rare cases where traces persist longer. Ancient mines, for example, leave scars on landscapes. Ore extraction changes geology, creating unusual concentrations of metals. Even if structures vanish, the chemical signature of mining can endure. Likewise, large-scale agriculture alters soils, leaving patterns of nutrients and erosion that can last for millennia. In some cases, these changes are visible from the air, as faint outlines of fields or roads. If another civilization had mined or farmed on a large scale, such patterns might remain. Yet so far, all evidence points to human activity alone. The question of traces also raises humility about our own legacy. We often assume our achievements will endure forever. Monuments, data, and cities feel permanent. But on geological scales, permanence is an illusion. The Earth is a restless editor, erasing and rewriting constantly. Our true legacy may not be monuments, but subtle chemical changes. Layers of plastic fragments, isotopes, and altered soils. To future eyes, these may appear as little more than a thin band in the rock, marking the Anthropocene, the age of human influence. It is sobering to realise that our most lasting impact may be unintentional. Carbon dioxide in the atmosphere, plastics in the oceans, radioactive isotopes in sediments. These may outlast our buildings and machines. If another civilization were to study Earth millions of years from now, they might identify a brief, sharp signal of industrial activity followed by silence. They might never know the details of our cultures, our languages, or our art. They would see only a chemical footprint, a faint trace of a presence that once was. And so, when people wonder whether we were truly the first, the answer depends on perspective. From the evidence we have, no earlier technological civilizations appear to have existed. The signals we would expect, artificial isotopes, unusual chemicals, or fossilized artifacts, are absent. But from the perspective of possibility, we must admit that detection is difficult. The silence of the record is not absolute proof. It is a reminder of how fragile memory is across deep time. As you rest with these thoughts, Imagine the city you know best, whether large or small. Picture it empty, vines crawling over buildings, animals moving through streets. Imagine centuries passing, then thousands of years, until the city is gone. Rivers have shifted, forests have reclaimed, and only faint traces remain. In the quiet of geological time, civilizations are not eternal. They are brief interruptions, flickers of complexity in a world that moves on. In the next part of our journey, we will shift from technology to biology, from cities to species. We will explore the detours of human evolution, the other hominins who walk this earth, and the possibility that intelligence itself might have emerged more than once. For if we ask whether we were the first civilization, we must also ask whether we were the first intelligent beings capable of making one. When we think about intelligence, we often think about ourselves, modern humans, with our languages, machines and societies. But our species is only one branch on a larger tree. For millions of years, Earth was home to many kinds of humans, cousins who walked upright, made tools, and survived in diverse landscapes. They are gone now, but their traces remind us that intelligence is not a single, inevitable path. It is fragile, branching, and sometimes cut short. If we wonder whether civilizations could have existed before us, we must first look at these other humans who nearly shared the title. The story begins with Homo erectus, emerging almost 2 million years ago. This species spread farther than any before it, from Africa into Asia and Europe. They made stone tools, controlled fire, and lived in groups. Fossils suggest they were skilled hunters, capable of persistence and adaptation. Their tools were simple compared to ours, hand axes, flakes and scrapers, but they were consistent, showing cultural transmission across generations. Homo erectus survived for over 1 million years, far longer than modern humans have yet existed. That longevity raises a question. Could a species so adaptable have taken steps toward more complex societies? The evidence suggests they remained in small groups, without the symbolic culture that defined civilization. But their persistence shows how intelligence alone is not enough. Conditions must align for complexity to grow. Closer to us were the Neanderthals. They lived across Europe and Western Asia from about 400,000 to 40,000 years ago. Stocky, strong, and well adapted to cold climates. They thrived in Ice Age landscapes. For many years, they were portrayed as brutish, but discoveries have reshaped that image. Neanderthals made sophisticated tools, used fire, and hunted large game cooperatively. They cared for injured members, buried their dead, and wore ornaments. Traces of pigment suggest they may have painted or decorated themselves. DNA evidence shows that they interbred with modern humans, leaving genetic legacies in many of us today. These details reveal a species with intelligence and culture, though not in the form of writing or large-scale cities. If intelligence can be measured in care, adaptation, and creativity, Neanderthals had it. Then there are the Denisovans, known not from skeletons but from fragments of DNA preserved in bone and teeth. Their presence stretches across Asia, and their genetic influence remains in some populations today, especially in Melanesia and Tibet. They likely had technologies similar to Neanderthals and modern humans. A Denisovan fragment of a bracelet, polished with tools, suggests fine craftsmanship. Though the record is thin, it shows that another branch of humanity, now gone, carried complexity and skill. What else they created, we may never know. Other species add to the picture. Homo floresiensis, discovered on the Indonesian island of Flores, stood barely over 1 metre tall. Nicknamed hobbits, they lived until about 50,000 years ago. using tools and hunting small elephants and large lizards. Homo naledi, found in South Africa, lived as recently as 250,000 years ago. They had small brains, yet evidence suggests they deliberately placed their dead in caves, a behaviour once thought unique to larger-brained humans. Homo heidelbergensis, a common ancestor of Neanderthals and Eos, showed signs of organised hunting and shelter building. Each of these species adds a chapter to the story of human variation. Taken together, these detours reveal an important truth. Modern humans are not the only beings who thought, created and adapted. Intelligence appeared in multiple forms. Symbolism, care for the dead, tool-making and social cooperation arose more than once. But none of these species developed what we call civilization: agriculture, cities and writing. Why not? The answer may lie in chance, climate and population size. Civilization requires not only intelligence, but also stability, numbers and continuity across generations. Without these, cultures remain mobile, flexible and small. For most of human history, survival did not require more. It is worth pausing here to imagine their daily lives. A Neanderthal group gathered around a fire, sharing meat after a successful hunt. A Homo erectus band moving across grasslands, carrying tools and caring for young. A Denisovan crafting a bracelet, polishing stone with patience. A Homo floresiensis family navigating dense forests, their small frames moving nimbly among trees. These were not primitive beings in the sense of lacking skill or care. They lived lives full of meaning, challenge and cooperation. Their intelligence was different from ours, but it was real. This perspective also deepens our question about lost civilizations. If multiple human species developed intelligence, then the possibility of complexity arising earlier becomes more plausible. But the evidence shows that while intelligence appeared repeatedly, civilization did not. For millions of years, humans lived as hunter-gatherers, adapting to landscapes without creating permanent cities. It was only within the last 10,000 years that agriculture and settlement transformed life. The gap between intelligence and civilization is wide. Many species crossed part of it, but only one completed the leap. Some scientists ask whether this leap was inevitable or accidental. Was civilization destined once intelligence appeared, or was it a fragile accident of geography and climate? The record suggests fragility. If climates had remained harsher, or resources scarcer, humans might never have settled. If Neanderthals had survived longer, perhaps history would have taken another path. If Denisovans had built larger societies, perhaps we would not be alone. Pained. The detours remind us that the future is never guaranteed. Genetics offers another clue. Modern humans carry small percentages of Neanderthal and Denisovan DNA. These fragments influence traits such as immunity, metabolism, and adaptation to altitude. In this way, the detours are not entirely lost. They live within us, shaping our biology quietly. Civilization may be our achievement, but it is built on foundations shared with cousins long gone. Their adaptations, carried forward in our genes, helped us thrive. From a geological perspective, the traces of these species are fragile. A few bones, a tooth, a cave painting, this is all that remains. The fossil record is incomplete, shaped by chance preservation. Whole populations may have left no trace at all. If entire species can disappear with only a handful of fossils, how much easier could an early civilization vanish without leaving evidence? The rarity of fossils reminds us how much we do not know, and how much may be hidden. As you rest, imagine walking through a Neanderthal cave. The air is cool, the walls marked with faint pigment. A hearth sits at the centre, ash still faintly visible. Bones lie scattered, showing signs of butchery. This was once a home, full of voices, laughter, and survival. Now it is silent, the echoes long gone. Yet from these small traces, we reconstruct a story. We see intelligence, family, and adaptation. We see ourselves reflected in a different form. The detours of human evolution show us that intelligence is not rare. It has arisen multiple times in different shapes and bodies. What is rare is the fragile chain of conditions that leads from intelligence to civilization. Agriculture, surplus, settlement, and writing are recent inventions. They rest on a thin foundation of climate stability and cooperation. If those conditions had not aligned, perhaps Neanderthals or Denisovans would have remained the most advanced beings on Earth. Civilization, in this view, is not destiny but chance. And so, the question of whether others came before us becomes both broader and narrower. Broader because intelligence is not unique to us. Narrower because civilization as we know it seems to have emerged only once. The detours remind us that we were not alone in thought, but we may be alone in building cities, machines, and histories that endure. In the next part, we will expand beyond Earth itself. We will look to the cosmos, to asteroids, impacts, and cosmic cycles. For just as catastrophes shape life on Earth, cosmic forces shape the possibility of civilizations anywhere. If intelligence is fragile here, what does that mean for the universe beyond? When we look at the night sky, we often feel a sense of stillness. Stars seem fixed, the moon rises and sets, and the planets drift slowly across the heavens. Yet behind this calm surface lies a universe filled with motion, energy, and disruption. Just as Earth's climate and geology have shaped the course of life, cosmic forces have played their part. Impacts, radiation, and cycles of solar activity influence not only the survival of species, but also the conditions under which civilizations can rise. To understand whether others might have come before us, or might exist elsewhere, we must consider this broader cosmic stage. Perhaps the most dramatic cosmic influence on Earth has been asteroid impacts. The most famous is the Chicxulub impact, 66 million years ago. A large asteroid, about 10 kilometers wide, struck near what is now the Yucatan Peninsula. The energy released equaled billions of nuclear weapons. Dust and debris filled the atmosphere, blocking sunlight, cooling the planet, and collapsing ecosystems. Dinosaurs, which had dominated for over 150 million years, perished. In their absence, mammals expanded and diversified, eventually giving rise to primates and humans. From destruction came opportunity, but the event also reminds us how fragile life is to forces beyond its control. If an advanced civilization had existed then, it too would have been erased, its traces buried under ash and rock. Impacts of this scale are rare, but smaller ones are more common. Craters across the globe, Barringer Crater in Arizona, Tunguska in Siberia, Chelyabinsk in Russia, are reminders that Earth remains vulnerable. Most impacts cause local rather than global damage, yet their possibility shapes our perspective. For civilizations, impacts are both threat and reset. They can erase progress, end eras, and alter climate. The question is not whether impacts occur, but when. Over millions of years, their certainty approaches inevitability. Beyond impacts, the sun itself shapes the rhythms of life. Solar activity waxes and wanes in cycles of about 11 years, affecting radiation, magnetic storms, and auroras. Larger cycles span centuries, influencing climate subtly but significantly. Periods of low solar activity, such as the Maunder minimum in the 17th century, coincided with colder temperatures in parts of the world, the Little Ice Age. For agricultural societies, such shifts could mean famine or migration. For early humans, they added another layer of challenge to already difficult survival. On a grander scale, the sun's gradual brightening over billions of years will eventually render Earth uninhabitable, though this lies far beyond human timescales. Cosmic radiation also plays a role. Supernovae, exploding stars, release high-energy particles that can reach Earth. Some scientists propose that bursts of radiation in the past may have influenced climate or even triggered evolutionary shifts. While evidence is still debated, the idea highlights how events far from Earth can ripple into our history. Civilization, fragile as it is, depends not only on stable climate and geology, but also on relative calm in the wider cosmos. Comets, too, have been suggested as agents of change. Their orbits bring them close to Earth at irregular intervals, sometimes colliding, sometimes passing by. Some theories connect comets with sudden climate changes, such as the Younger Dryas cold period around 12,900 years ago. Though evidence is mixed, the possibility illustrates how cosmic visitors can influence life on Earth. For early humans, the sight of a comet must have been awe-inspiring, a bright streak across the night sky, unpredictable and mysterious. For us, it is a reminder that the universe is dynamic, not static. When we widen our view further, we see Earth itself travelling through the galaxy. Our solar system orbits the centre of the Milky Way every 225 million years, passing through regions with different densities of stars and gas. Some scientists speculate that as we move through spiral arms, the likelihood of impacts or radiation events increases. Over geological time, Earth experienced cycles not only from its orbit around the Sun, but also from its journey through the galaxy. Civilizations, if they arise, must do so within windows of stability between such disruptions. All of this leads to a broader reflection. If civilization is fragile here, under the conditions of Earth, what does that mean for the universe? The silence we hear when we look outward, what scientists call the Fermi paradox, may be explained by fragility. Civilizations might arise, but cosmic events may erase them before they spread. Or they may be limited in duration, existing briefly before fading. The universe could be full of beginnings, each interrupted before it becomes visible to others. From a sleep perspective, imagine lying beneath a clear night sky. Stars stretch across the horizon, ancient light arriving after travelling for thousands of years. Somewhere among those stars, planets orbit quietly. Some may be barren, others rich with life. But even if life thrives, it faces the same cosmic challenges we do: impacts, radiation, cycles of change. Civilizations may rise, only to be silenced by forces larger than themselves. The cosmos, vast and indifferent, sets the stage but does not guarantee the play. Yet within this fragility lies resilience. Life has survived multiple mass extinctions on Earth. From the ashes of catastrophe, new forms arise. Mammals flourished after the dinosaurs fell. Humans emerged after countless evolutionary detours. Civilizations, too, may rise again even after collapse. The cosmos may challenge, but it also provides opportunities. Each quiet period between catastrophes is a chance for growth, a chance for intelligence to try again. For our own world, the cosmic perspective adds humility. We may feel advanced, but we remain vulnerable to events far beyond our control. Our technology can track asteroids, measure solar cycles, and detect radiation, but it cannot stop them entirely. civilization is not only shaped from within, but also tested from without. To last, it must navigate both human fragility and cosmic chance. It also adds meaning to our search for life elsewhere. When we send probes to Mars, Europa, or exoplanets, we are not only asking whether life exists, we are asking whether civilizations can endure. If we find signals, they may be rare survivors of cosmic trials. If we do not, the silence may reflect the same fragility we face. Either way, the cosmic perspective expands our sense of time and possibility. As you rest, imagine Earth not as a static world but as a traveller. It spins on its axis, circles the Sun, and drifts through the galaxy. Each movement brings both stability and risk. Impacts may come, stars may explode, climates may shift. Yet amid these cosmic forces, life persists, adapts, and sometimes flourishes. Civilizations, brief though they may be, are part of this larger rhythm. We are both fragile and resilient, fleeting and enduring. In the next part, we will return from the cosmic scale to the rhythms of Earth itself. We will explore deep time, the cycles of climate over hundreds of thousands of years, and how humans lived within them. For if we are to understand our place in history, we must see ourselves not only in centuries, but in the vast spans of geological time. When we think about history, we often imagine centuries or perhaps a few millennia. We measure by dynasties, empires, or generations. But the Earth does not measure in centuries. Its story unfolds over millions and billions of years. To step into this scale is to enter deep time, where continents drift, mountains rise, and climates shift in rhythms so vast they are almost beyond comprehension. If we are to understand how civilizations fit into Earth's story, whether ours is the first or one of many, we must first feel the weight of deep time. The Earth itself formed about 4.5 billion years ago. At first, it was a molten world, bombarded by asteroids and comets, its surface unstable and hostile. Over hundreds of millions of years, it cooled, oceans condensed, and continents began to take shape. Life appeared early. Microbial traces as old as 3.5 billion years have been found. For billions of years, life remained simple: bacteria, algae, and microscopic organisms. Civilization, cities, even animals were far in the future. Yet even in these early stages, the Earth was laying the foundations: oxygen in the atmosphere, carbon cycles, stable climates, that would later allow complexity. Plate tectonics, the movement of Earth's crustal plates, is one of the main forces of deep time. Continents drift, collide, and split apart. Mountains rise, then erode. Oceans open and close. The supercontinent Pangaea existed about 300 million years ago, uniting almost all land into one mass. Before Pangaea, there were others: Rodinia, Gondwana, Laurentia. Each lasted tens or hundreds of millions of years before breaking apart. If civilizations had existed in such distant times, their continents themselves may no longer exist in recognizable form. Entire landscapes are swallowed, melted, and remade. Deep time does not preserve easily. Climate, too, has cycled across scales beyond human memory. Ice ages have come and gone repeatedly. In the last 2.5 million years alone, more than 20 glacial cycles have occurred. Ice advanced, covering much of North America, Europe, and Asia, then retreated again. Each cycle lasted tens of thousands of years, reshaping coastlines, ecosystems, and habitats. Humans evolved during this period, adapting to changing environments. But if we look further back, climates have been even more extreme. There were times when Earth was almost entirely covered in ice, so-called snowball Earth events. hundreds of millions of years ago. At other times, the planet was far warmer, with no ice at the poles and tropical forests near the Arctic. Civilizations could not have endured such extremes. Life itself struggled. Mass extinctions punctuate deep time. The Permian extinction, about 252 million years ago, wiped out most species. The Cretaceous extinction, 66 million years ago, ended the reign of dinosaurs. Each reset life's trajectory, clearing space for new forms to arise. Humans are the product of these resets. Without the extinction of dinosaurs, mammals might have remained small, nocturnal creatures. Extinctions remind us that survival is not guaranteed, and continuity is fragile. Civilizations, if they existed earlier, would have faced the same disruptions. Their traces erased along with the species that supported them. Fossils are the main voices we hear from deep time. Shells turned to stone, bones mineralized, leaves preserved in rock. Yet fossilization is rare. Most organisms vanish without a trace. For every fossil we uncover, millions more lived and died unseen. The record is patchy, full of gaps. This means that even entire species can vanish with almost no evidence. If we struggle to reconstruct the lives of creatures millions of years ago, how much harder would it be to detect a civilization, fragile and brief, in the same record? Human time feels tiny against this backdrop. Modern humans, Homo sapiens, have existed for about 300,000 years. Written history covers barely 5,000 years. Civilizations with cities, agriculture, and writing are only a few thousand years old. Against billions of years, this is less than a blink. Imagine a clock representing Earth's history compressed into 24 hours. Life appears at about 4 a.m. Complex animals emerge around 9 p.m. Dinosaurs rule from 10 p.m. until 11:40 p.m. when they vanish. Humans arrive at 11:58 p.m. All of recorded history from Mesopotamia to today fits within the last few seconds before midnight. That is how small we are in deep time. And yet, despite our brevity, humans seek to know this vast story. We drill ice cores from Greenland and Antarctica, reading trapped bubbles of air that tell us about climates stretching back hundreds of thousands of years. We study sediments, counting layers like pages in a book, each grain a record of past rivers or winds. We measure isotopes in rocks to track temperatures, volcanoes, and solar cycles. These methods allow us to glimpse deep time, to step outside the limits of memory. They also show us how fragile the traces of civilizations would be. Only in very unusual conditions do artifacts survive long enough to enter the geological record. Consider again the span of 1 million years. In that time, continents shift, rivers carve new paths, mountains erode, glaciers may come and go. Insects, plants and animals evolve and vanish. Civilizations, even if they lasted tens of thousands of years, would be reduced to thin lines in rock. Their cities might crumble, their machines corrode, their languages vanish. The memory of their existence would depend on luck. An artifact buried quickly, a chemical anomaly preserved, a fossilized trace. Without such luck, deep time would erase them. This is why scientists remain cautious. The silence of the record does not prove that no earlier civilizations existed, but it makes the possibility unlikely. If we, with our vast technological reach, would leave so little behind in 1 million years, what chance would earlier civilizations have? And yet, the gaps remind us that absence of evidence is not the same as evidence of absence. Deep time humbles us with both certainty and uncertainty. For those listening now, as you lie in the quiet, imagine standing on the edge of the Grand Canyon. Each layer of rock represents millions of years. At the base are stones older than life itself. Above them are layers from ancient seas, deserts and forests. Fossils appear in some, absent in others. Together they tell a story too vast for one lifetime. Now imagine asking, where in all this stone would a civilization appear? Perhaps as a thin line, a dark band of soil, a rare artifact. A whisper in the rock, quickly overwhelmed by the next cycle. That is the weight of deep time. It is both humbling and calming. Our worries, our empires, even our civilizations are brief. The earth has seen countless ages, and it will see countless more. Mountains rise and fall, oceans come and go, species appear and vanish. Civilizations are temporary arrangements, flickers of order in a restless world. Yet within these flickers lies meaning. We are part of the story, however brief. To know deep time is not to despair at our smallness, but to find perspective in it. In the next and final part of our journey, we will return to the present. We will ask what meaning we can take from this long exploration and how to rest with the knowledge that civilizations, fragile and brief, are part of Earth's ongoing rhythm. The story of Earth is long, but tonight we have walked through one of its chapters. The rest will wait for another time. We have travelled far together, across ice and stone, through oceans and vanished lands, alongside mammoths, Neanderthals, and empires long forgotten. We have stepped into deep time and looked outward to the cosmos. And now, as we arrive at the end of this journey, it is time to bring the threads together in quiet reflection. The Earth remembers through layers, sediments, fossils, isotopes. It keeps records, but they are incomplete. Pages are torn out, rewritten, or buried beyond reach. From these fragments we have tried to understand whether we are truly the first civilization. What we found is a record filled with silence. No clear evidence points to civilizations before ours. But silence is not certainty. It is an open space, where imagination lingers. The Earth, after all, forgets easily. We saw how fragile even known civilizations are. The Akkadians faltered under drought. The Indus cities dispersed as rivers shifted. The Maya abandoned their pyramids when rains failed. Each collapse was not sudden, but gradual, a slow unweaving of complexity. If such fragility is the fate of societies with stone and writing, how much more fragile would earlier ones have been? Perhaps they left no mark strong enough to endure deep time. We saw too the role of catastrophe. Asteroids, volcanoes, and climate cycles have repeatedly reset life's path. Mass extinctions erased the dominant species of their day, opening space for others to rise. Dinosaurs yielded to mammals. Mammals eventually gave rise to us. Each chapter depended on chance. If a rock had not struck Earth 66 million years ago, there might be no humans here to wonder at all. If another rock strikes tomorrow, what we call civilization could vanish just as quickly. We considered intelligence beyond us. Neanderthals, Denisovans, Homo erectus, and others. They made tools, cared for each other, and even created art. They were not us, but they were not so far from us either. Their intelligence was real, their lives filled with meaning. Yet none crossed the threshold into cities, writing, or complex economies. Intelligence alone was not enough. Conditions had to align. Climate stability, population growth, and cooperation. Perhaps it was only by chance that Homo sapiens crossed this threshold. If so, our civilization is not destiny, but accident. We also looked beneath the seas, to Doggerland, Beringia, and Sunderland. Lands where humans once walked, now drowned. If early settlements stood there, Their remains are hidden beneath waves and sediment. Oceans conceal much of human history, and perhaps many secrets remain there still. But exploration is young, and the sea is vast. What has been lost may remain forever silent. In thinking of traces, we asked what endures. Stone, ceramic, and isotopes last longer than steel, glass, or electronics. Our most lasting legacy may not be monuments, but chemistry. A thin line of plastics, metals, and radioactive elements preserved in rock. To a future geologist millions of years from now, the entire human story may appear as nothing more than a faint signal, a brief anomaly in Earth's long record. What feels monumental to us is a whisper in stone. Through all of this, deep time reminded us of perspective. Our species is young, barely 300,000 years. Our civilizations are younger still, only a few thousand years. Against billions, this is less than an instant. If Earth's history were a single day, our story would be a few seconds before midnight. And yet, in those seconds, we have built machines, written libraries, crossed oceans, and walked on the moon. Small though we are part of the Earth's memory, and perhaps part of the universe's as well. So, are we the first? From the evidence we have, yes. No earlier civilization appears in the stone, the sea, or the sky. Yet the question itself is valuable because it reminds us of fragility. Civilizations are not permanent. They rise, they falter, and they fade. Even ours. To see this clearly is not despair, but clarity. It reminds us that what matters most may not be how long civilizations last, but how deeply they live while they do. And now, as we close, imagine the Earth continuing its quiet rhythms. Mountains rising slowly, rivers winding their paths, glaciers carving valleys, forests spreading and retreating, oceans rising and falling. Civilizations will come and go, but the Earth continues, steady in its turning. You are part of that turning, a moment within its vast story. Let the thought bring calm. The weight of deep time is heavy, but it also frees us. Our worries, our struggles, our triumphs, they are brief, yet they are real. The Earth holds them gently, even if only for a moment. You have walked through one of its chapters tonight. The rest will wait for another time. The planet never sleeps, but you can. Let the Earth keep turning while you rest. If you would like more journeys like this, you are welcome to return here again. Good night.